vertical projectile motion. We then need what? The equations of motion. And we learned these equations of motion from today. Again, they are still the same, but what's changed is now the dimension. We are now dealing with what? The vertical dimension. Okay. So it means now, whenever we want delta x, x represents the horizontal. Okay? We're going to replace it by delta y. Okay. Then, because we are dealing with up or down motion. Okay. Now the first equation says Vf equals to Vi squared plus 2a delta y. And then Vf equals to Vi plus a delta t. No need to cram there because this is given to you in the formula sheet. When you must just know what? You must just know
how to apply them. Yes.
You must now know how to use them. And then guess what? I'm going to make an asterisk there. I'm going to make what? An asterisk. I must now make an asterisk. We'll talk about that. For now, why did I make an asterisk? Why did I make an asterisk? Now it's here. Vf equals to Vi squared plus 2a. When you go perfect. Vf, Vi, a delta t. Again. How can I Vf equal to final VI initial velocity and then A acceleration due to and then displacement. And then time. Now, what can you say about those? What can you say about those? What can you say about? What can you say about VF? What can you say about VI? What can you say about delta Y? What can you say about A? What can you say about these physical quantities? This A is acceleration due to because you already know that when we are dealing with a projectile and it's in free fall, the only force that is acting there is force of gravity. So it has to be accelerating due to what? Due to gravity. So the acceleration of that object will be acceleration due to gravity. Acceleration you. Not in most cases. In all the cases, when our projectile is in free fall, A is our gravitational acceleration, and we will always know its magnitude. That if it is on F, its gravitational acceleration will be 9.2 meters per second squared. Again, remove. What can you say about this? VF, VI, delta Y, A. They are vector quantities. These are vector quantities. These are vector quantities. And we know what is a vector. We know what is a vector. What is a vector? It says to us that when I have VF, VI, delta Y, and A, these are what? Vectors. It means where I see them, I must have their magnitude and direction. Always, always, when I see VF, VI, delta Y, and A, they must always have magnitude and direction. They must always have magnitude and direction. Next. Now, actually, these equations of motions are the ones that are going to help us to solve the projectile motion. And what is important is that when using these equations of motion, I will say number 1, number 2, number 3. Okay? You see these ones? Those ones, you will never go home with. What is the reason? What is the reason? Look at this. Look at equation number 1, number 2, and number 3. They have acceleration. They have acceleration due to, look, equation number 1 has A. Has A. And then also this one has A. And we know that A is our what? Gravitational acceleration. And we know that if the object is in free fall, we will always know the acceleration. That it will be 9,8. Its acceleration. So this one, you see I've written it as A. Why? Because there is no acceleration due to gravity. No, you can still use it to solve any projectile motion problem. But now, I don't like it. Why? Because it does not have this acceleration due to gravity. This one. Yeah, they should give you the same answer. This delta Y and this one and this one. They should be the same. What I like about this one, remember, for you to use equations of motion, how many variables do you need? Only need 3 variables. So if I'm using this one, 1, 2, and 3, there is taking only 1 complete. Then I'm left with how many? 2. So when I'm using this one, it's a problem if I don't have the 3 complete. This one, I already have 1. Then my task is to do what? Is to find the other 2. And they will be there in the problem. They will be there in the it can still work. Perfect this week. But now it is going to waste my time. This one, I'll only have to find how many variables? 2. Because the third one I already know. It is what? The gravitational acceleration. Are we together? Are we together? Are we together? Yes. Are we together? These are vectors. They must have magnitude and direction. Now let's answer. How are we going to choose this direction? Let's look at that's easy to help us to have now the choice of direction. Because already I see that before I can use my equations of motion, I must now know the direction and the direction. It's up to me to choose the direction. It's up to me to choose the direction. It's up to me to choose the direction. Now, direction says you can either choose, remember our projectile. It's either going up or down. Now, so our choice of direction then comes to say you can choose up to be positive. Or you can choose down to be negative. Unless the statement forces you to choose, says take up as positive. If the statement does not say that, then the choice is yours. But we're going to look at the both of them. Okay? Now, hurry. If now we say up is positive, what does it say about the object that is going down? Down must be negative. Okay. Where is G? Now, the G then comes to us and says, if you choose up to be positive, A or G, A, I will use A because here we have A. If you say up is positive, A, which is gravitational acceleration. Gravitational acceleration will be negative. Because you said up, anything that goes up must be positive. And then gravitational acceleration is due to what? Is due to the force of gravity. And the force of gravity acts where? Again. So A has to be negative. Why does it have to be negative? Because the gravitational force pulls objects down. And if up is positive, anything that goes down should be negative. So acceleration due to gravity when you take up as positive, you must always know that gravitational acceleration is negative because it acts in the opposite direction of your choice of direction. Because you chose what? Up as positive. G yona ya for A goes. And for anything that is going down, it has to be negative. Round up. Yes. That's now up to be positive. And then if now we say up is negative, down will be positive. The opposite is remember, unless the question states otherwise, the choice of direction is yours. So if you choose up to be negative, it means everything that goes down must be positive. Okay. What will be the direction of A? A will be positive. And we know its magnitude. Is that a guy? This negative shows us the direction. Come on, I tell them now. Plus negative 9.8 meters. Got it? This class shows us now it shows down to be positive. This here shows that the negative here means now down is negative and up is positive. Are we together? Are we together? Yes. So when we meet, for us to be able to give the others their direction, we now need a scenario. So we'll start here when we meet. Amen. Yes.